So today, as part of our regular biochemistry practicals, so I want to discuss about the estimation of serum total proteins by Biuret method. So it is a quantitative experiment. So with the help of Biuret reagent, we are going to quantify the amount of proteins present in the blood sample. So normally protein is a very important for the maintaining of the oncotic pressure in order to transport the drug molecule to different parts of the body. So this protein generally will estimate in two methods. So this is the one method, that is the Biuret method. It's a graphical type. The second one is the kit method. So they directly will take the protein, will add that to the reagent, automatically will get the volume, will get the concentration of the serum total proteins. In these two ways, generally we will do the experiments. So today I want to discuss about the first method, estimation of total proteins by Biuret method. So what are the requirements in order to proceed the experiment? So the very important requirement is our actual reagent Biuret. So how we are going to prepare the Biuret reagent? So this Biuret reagent will prepare in two steps. The step one is we have to weigh 3 grams of copper sulfate powder, and to this we have to add 9 grams of sodium potassium tartrate. So dissolve these two in 500 ml of the 0.2 molar NaOH solution. That is the step one. Step two. So to the above mixture, add 5 grams of potassium iodide and make up the final volume up to 1 liter with the 0.2 molar NaOH solution. In this way, we will prepare the Biuret reagent. If any undissolved part is there, so no need to worry. You just filter the sample, filter the reagent automatically. You can remove the undissolved particles. Automatically, you will get a clear solution. So in that way, we will prepare the Biuret reagent. That is the first requirement for the experiment. So the second requirement is the preparation of the standard. So as this is a graphical method, in presence of blank, we are comparing series of standards with the test. So for that, we have to prepare the standard. How we are preparing the standard? So here we are using albumin, that we call as the bovine serum albumin. We call it BSA. Generally, in the market, it was available in powder form. We will take this powder, and by using the powder, we will prepare the 5 mg per ml protein solution. This is the concentration of our standard. So one important thing you need to remember is that the standard concentration for today's experiment is 5 mg per ml. So 1 ml of each solution contains 5 mg of the protein. So for that, we are using the bovine serum albumin. So that is the second important requirement of the experiment. The other requirements are the test tubes, micropipettes, pipettes, and so this. In order to analyze, we have to take the centrifuger, and here as a test sample we are using plasma. So generally plasma, how we are collecting means first we take the blood sample. So this blood sample will centrifuge, automatically we will get the serum. That serum we use as a test sample. Generally we will take very low volumes, so we will take 10 microliters or 20 microliters like that. Okay. With that we will prepare the test and we will assess the amount of protein present in the test sample by comparing with the standard. So these are the important requirements to do the experiment. The next principle in the experiment, as we all know, so Biuret we are preparing with the help of copper sulfate, and the sodium potassium tartrate and potassium iodide, they will provide the favorable medium for the reaction of the copper with the protein. So this is the one small peptide. It's very difficult to write the total protein. For that reason, I mentioned a small part in the protein that we call the peptide. So these are the peptide linkages. So here, the protein, the peptide linkages present in the protein, they will react with the copper. So they will form a complex. Generally, this complex will be in blue or violet color. Based on that color only, we are quantifying the amount of protein present in the test sample based on the intensity. So very simple. So the copper present in the reagent will react with the protein, will form a complex. The complex will be in blue or violet color. So the intensity of blue or violet color complex, we are comparing in presence of blank with the standard test at 540 nanometers, and we are quantifying the amount of protein present in the test sample or serum. So that is about the principle involved in the estimation of the serum total proteins by Biuret method. So next, we'll go to the procedure. The procedure of the experiment. So very simple. You mention the procedure in a small table with the 6 columns. So one will mention as the serial number or the name of the test. So in the 6 columns, the first column is about the serial number. The serial number will mention the name of the test tube. Generally, for the experiment, we will take 7 test tubes. The 7 test tubes will label as one as blank, remaining as a standard 1, standard 2, standard 3, standard 4, standard 5, and the last test tube as the tester. In this way, we label the test tubes. We'll make the things ready. Next, in the second column, we'll take the standard volume. So, in order to prepare different standards, we need to add different volumes of the standards. The third column is the standard concentration. So, we'll calculate the amount of concentration of that standard. In the fourth column, we'll mention about the distilled water. In order to make the uniform volumes, so we'll dilute the solutions with the distilled water and we'll make the uniform volume. Next, we'll add the reagent, and finally we'll incubate at room temperature for some time. Then, with the help of colorimeter at 540 nanometers, we'll measure the optical density values. So, this is the procedure table. So, now I will explain one by one. So, first regarding the blank preparation. Generally, this blank preparation, so blank means it does not contain the standard. So, the standard concentration is 0. So, directly we will take 1 ml of the distilled water, and to this we will add 3 ml of the Biuret reagent. Okay. Next, standard 1 preparation S1 we will call as 0.2 ml of the standard solution. Next, 1 ml, 0.8 ml of the distilled water. So, this 0.2 ml plus 0.8 ml altogether will produce 1 ml. So, finally, we will make all volumes to 1 ml with the distilled water. So, that is the one important note point. And then we will add the 3 ml of the reagent. Next, regarding the standard 2, we will call as the S2. The preparation of S2, 0.4 ml of the standard, 0.6 ml of the distilled water, 3 ml of the reagent. S3, 0.6 ml, 0.4 ml, and 3 ml of the Biuret reagent. Next, S4, 0.8 ml of the standard volume, 0.2 ml of the distilled water. Automatically will produce 1 ml, and to this mixture we will add 3 ml of the distilled water. S5, 1 ml of the standard volume. So already we are taking 1 ml of standard, so no need to add the distilled water. Next, 3 ml of the Biuret reagent. So regarding the test preparation, we will take 20 microliters of the serum. So this will add 1 ml of the distilled water. Finally, we'll add the 3 ml of the reagent. So in this way, we'll prepare the test. So now I will show one by one how we have to prepare the blank, standards, and test. So for this, you need to do is one standard, the another one is distilled water, the third one is the reagent, fourth one is the serum. First, you need to make the things ready. And one more important point, you label the test tubes. So that is the labeling is a very important point in order to reduce the confusion. So this is the protein solution that we prepared. Okay, so now I will use this as a standard, and with this I will prepare different standards. By using pipette, you transfer this protein into the labeled test tubes. So first I am preparing the standard one. So as you know, so we have to take 0.2 ml of the standard. So transfer 0.2 ml of standard into the S1, then 0.4 ml into the S2, so in order to get correct values, so you transfer the exact volumes automatically, then only you will get the correct value. So then for the S3, you transfer 0.6 ml of the standard. Then 0.8 ml. Into the S4 tube. Then into the S5, transfer 1 ml of the protein solution. So make the uniform volumes with the distilled water. So in the S1, already we added 0.2 ml of the standard. So we add 0.8 ml of the distilled water to make the uniform volume. Then into the S2, we already added 0.4 ml. So add 0.6 ml. S3 already we took 0.6. So add 0.4 ml. S4 already we took 0.8 ml of the protein standard. So add 0.2 ml of the distilled water. So for the S5 already we added for the S5 already we added 1 ml. So no need to add the distilled water. In that way, prepare the standard and distilled water solid mixtures. Now blank. Regarding the blank, in the blank preparation, so we have to take 1 ml of the distilled water. So take 1 ml of distilled water. In the case of test also, take 1 ml of distilled water and add 20 microliters of protein. Now, to all these preparations, add reagent. Now add reagent, 3 ml of the reagent. So this is the blank. Then one by one in a series we add the reagent. Now you can observe slowly the reaction is happening. Slowly the color change was observing. So after 2 more minutes you can get the clear change. So in that way, one by one we add the stranded distilled water and the reagent. Slowly the reaction will happen and you can observe the formation of the blue or violet color. Here in this case we observe the violet color. So you can observe. So this one is the S2, S3, S2, S3, S4, S5. Slowly the color intensity you can observe. You can observe the color change also. Here the color is very light. So very little bit reaction because of low amount of protein concentration. Whereas S5, because of high amount of protein, there was a good reaction. You can get a dark color. So this is the case of blank. So you won't observe any color change. The next part in the experiment is the measurement of the concentrations. So regarding the test preparation, so take 20 microliters of serum, to that add 1 ml of distilled water, 3 ml of reagent. Already I added reagent and distilled water. Now to this we add 20 microliters of the serum. Slowly you can observe the intensifying of the color because of the reaction of carbon present in the reagent with the peptide bonds of the protein. So slowly you can observe the darkening of the color also. So after preparation of the mixtures, incubate the preparations at room temperature for 5 minutes. So then we will get the reactions, we will get the color changes also. So see, you can, these are the, like these color changes you can observe. Okay, now the thing is measurement of the optical density values by using colorimeter at 540 nanometers. So in the measurement of the optical density values, the step 1 is the, so first we have to take the blank, we have to auto zero the instrument with the blank. So for this what we have to do? So take the blank in the tube and adjust the wavelength to 540 nanometers. Then keep the blank tube in the sample feeding knob and adjust to 0.00 by adjusting the adjustment knob. So in this way you have to get in this way you auto zero the instrument. After auto zeroing with the blank in a series, we can measure the absorbances of the S1, S2, S3, S4, S5 and test. So now take S1. So keep it in the colorimeter. So note down the optical density values. So it is 0. So with the blank, the optical density value is 0.0. So with S1 it is 0.07. Next S2. So this is S2. So the value with S2 is 0.17. Then prepare the S3. The reading with S3 is 0.25. So prepare the S4. So the reading with S4 it is 0.33. Then you measure S5 absorbance. So the S3 absorbance is 0.47. So now with this, the standard measurements were completed. Now measure the absorbance of the test. So this is the test. So similarly, measure the absorbance of the test also and note down the absorbance. So the test absorbance is 0.16. So note down that in the table. The test absorbance is 0.16. So now, so with the help of the readings, draw the straight line, then intercept the test OD value with the graph and measure the concentration of the test sample. So for that, what we have to do? First, we have to take the graph paper. Horizontal one take as the x-axis. On the x-axis, we are taking the standard concentration. The units is mg. On the y-axis, we are taking the optical density values. So now the scale of the graph on x-axis 1 centimeter is equal to 1 mg. On y-axis, you take 1 centimeter is equal to 0.1, 0.2, 0.3, So on x and y axis we are taking the CL 1 centimeter is equal to 0.1. So 1 or we are also called as the 0.10. So now draw the points and tie a straight line. So first, so S1, the concentration is 1 mg and the reading is 0.07. So you make the point on the graph paper. So this is the one. So around here we will get the 0.07. Next, 2, the S2, the concentration is 2 mg. The OD value is 0.17. So that is S2. Then S3, the concentration is 3 mg and the OD value is 2.5, sorry, 0.25. So this is the 3. So 0.25 means this is the middle. In the middle, we will get the 0.25. So here we will get 0.25. Then S4, the S4 concentration is of 4 mg and the optical density value is a 0.33. So you take that one. So 0.33 means around here we start. So that is S4. So then S5, the concentration of S5 is 5 mg and the optical density value is 0.47. Somewhere around here we will get 0.47. So that is the S5. So in that way you mark the points on the graph field and now from the origin. So this is the origin. So from this origin you draw a straight line. So that has to touch maximum points. So now for me, so the straight line was intercepted with the first point S1 and S4. So in that way, you draw a straight line. So that is the step one, drawing of the straight line. So now, so by using this test OD value, you measure the concentration of the test sample. So for that, what I have to do? So first you make the point on the graph paper. So 0.16 is in between 0.1 and 0.2. So this is 0.15. So 16 means it is somewhat higher. So you will get point around here. So from that, you draw a straight line parallel to x-axis. So in that way, you draw a straight line parallel to x-axis. And somewhere it will intersect with the straight line. Now after intersection, again you draw a straight line that will touch the x-axis. So now it intercepted on the x-axis here, that is at 2.1. 2.1 mg. So now the calculation. So now regarding the calculation of the test concentration, already by intercepting the test body value with this white line, we got 2.1 mg. So by using that, we will calculate. So we took 20 microliters of the test sample, 20 microliters of serum. This 20 microliters of serum contains 2.1 mg of the protein. So now 100 microliters. 100 microliters will have 2.1 mg into 5 times, means 10.5 mg. So 1000 microliters is equal to 1 ml. So 1 ml of the test sample contains, so 10.5 mg into 10. So we will get 105 mg. So the concentration of the test sample is 105 mg per ml. So 1 ml solution contains 105 mg. So in a generally we have to report in the mg per dl. So for that you multiply that concentration with the 100 ml. So 100 ml contains, so means 1 ml contains 105 mg. That we will multiply with the 100. So automatically we will get the concentration for 100 ml. So it contains 10,500 mg. So you convert that into grams. So we know already 1000 mg is equal to 1 gram. So you divide with the 1000, automatically you will get 10.5 grams. Now the concentration of the protein is 10.5 grams per deciliter. Okay. So the amount of protein present in the test sample was found to be 10.5 gram per deciliter, or you can also report in 105 mg per ml. So in that way, we'll prepare the procedures, we'll take the graph and we'll draw a straight line, and with the OD value, we'll intercept the graph and we'll calculate the test concentration. Finally, we calculate the test concentration for 100 ml. Generally, it is a protein. Generally, proteins are present in the grams. So generally, we will represent with the gram per dl unit only. So for that reason, you have to convert the mg per dl into gram per dl. So because of that reason, we got the value 10.5 gram per deciliter. And one more important thing, serum normal value of serum total protein is 6.5 to 8.5 gram per deciliter. 6.5 to 8.5 gram per deciliter. So that is the normal serum total protein concentration. If the serum total protein concentration is more than 8.5 gram per deciliter, we will consider as a hyperproteinemia. Generally, this hyperproteinemia condition, it is abnormal. Generally, it will present in the persons who are taking continuous high amount of protein intake diet. The opposite condition is the hypoproteinemia. So if the protein value is less than 6.5 gram per deciliter, that we call as a hypoproteinemia. So the causes for hypoproteinemia are, so low protein intake, renal failure, liver failures. These three are the very important conditions. So in those conditions, we will observe the hypoproteinemia. Okay. So by using the serum total protein, we will identify the liver diseases, and we will assess the kidney failure, and we will assess the proteinuria chances also. and we will assess the protein intake of the person. Generally, in the case of malnutrition persons, we will observe the low amount of proteins because of the low consumption of protein. The total protein concentration in the blood will be less than 6.5. So that is about the experiment estimation of cell total proteins by Biuret.